Hello everyone, welcome to this short demo tutorial on AWS. These are our agenda for today. Introduction to cloud computing, different cloud service and deployment models, analogy of AWS with corporate data center. What is cloud computing? So the cloud computing has two different terms. One is cloud and the other one is computing. So what is cloud? Cloud is nothing but internet or intranet. So I said internet or intranet. That's it. No more, no less. That is the definition of cloud. And computing. What is computing? So computing as a whole is equal to the RAM size, the compute power, and a little bit of the storage part. So I'll bring in one more variable, which is called virtualization. So what is virtualization? So let me show you a little bit of diagram here. Suppose you have a computer which is Windows. We have Windows operating system installed on this computer. Right now, you have to, for some reason or the other, what you have to do is have to have a Linux machine or a Macintosh machine or an Apple computer. So you cannot do it on Windows, right? So for example, for some reason you need two different machines with two different operating systems. One is Linux and the other one is Mac OS. What are the options you have? So of course you have an option of buying two more computers, one with Linux operating system and the other one with Mac OS operating system. These are the options. This is one of the options that you have. What is the other option? So now if you see here, before going to the other option, if you see, you have to have three machines all the time. So it will cost you, it has costed you some amount to buy Windows machine. It will cost you some more amount to buy Linux and a lot more to buy Mac OS. And the funny part is that you won't be using Linux and Mac OS all the time. You might be shutting it down most of the times, and most of the times you'll be using Windows operating system. So the question is, what is the point in buying a new machine, right? Of course, that's not how it should be. We have one more option here. Instead of buying Linux operating system, what we could do is we could bring in something in between. We can install something in between. I'll give the easiest example, which is VMware. So most of us have used VMware. That is called a virtual machine or a hypervisor. So what you can do, how you can get rid of buying altogether two new machines? You install VMware and then you install Linux and Mac operating system on this VMware. Right, problem solved. Now the thing is, you can install both Linux and Mac operating system on top of VMware. So you are not buying three different machines. You have one machine which has Windows operating system running on it. The one additional thing which you have done is you have installed VMware, and using on top of VMware you have installed Linux and Mac OS machine. Right. Of course, you would need these operating systems, which you would need anyway. But in this case, you have averted buying two new machines or spending a lot of money altogether. Now, in this case, also you can use Windows whenever you want. You can use Linux whenever you want. You can use Mac OS whenever you want on the same machine. So this technology, whatever you are seeing here, this technology is called virtualization. So the thing which I have done from here and above is virtualization. So this Linux operating system is a virtual operating system. So this macOS this macOS operating system is sitting on a virtual machine which is getting run by VMware. So that's what virtualization is. And virtualization has been made popular by cloud services. AWS also uses virtualization. How it uses? Let me So instead of Windows machine, what you can do here is, instead of installing VMware on top of Windows operating system, what you could do, you could install VMware directly on a hardware. So this is your VMware, and you have installed, in this case there's no Windows operating system, this is your hardware. You have your RAM, you have your CPU, and you have your CPU, RAM, storage, or hard disk, whatever you might say. Basically you have your hardware here. So what you're doing, you are skipping the operating system in between, which is Windows. So instead of installing VMware on Windows directly, you are installing VMware on the hardware as a whole. Now you do exactly the same thing as we were doing earlier. You install 3 operating systems on top of VMware. One would be Windows. This will be Windows operating system. This will be Linux operating system, any Linux flavor. This will be Mac operating system. So this VMware here is called hypervisor. This is called a hypervisor. So AWS uses the exact same feature, the exact same technology. Instead of VMware, or not only AWS, any cloud services, instead of VMware, it uses something called Zen. So as I say, this is a virtualization technique. This is what is getting used. So that's what virtualization is. Now the final definition of cloud computing. So providing virtualized compute environment over internet or intranet. That is the full and final one-liner definition of cloud computing. So you have cloud, that is internet or intranet. Then you have computing, that is a virtualized compute environment, as I have just shown you. Combine both of them and you get a cloud computing environment. So that is the definition of cloud computing. Right. So now I'll go ahead and discuss the different cloud service and deployment models. So there are different types of cloud service models, but before that, let us discuss a little bit about on-premise data center. So we have our on-premise data center here. If you see, the organization is responsible for maintaining and maintenance of the entire data center bottom up, except for network, because most of the times network is provided by some third-party vendor. So network is maintained by organization as well as a third-party vendor, but rest all, storage, server, virtualization, operating system, database, application, security, everything is controlled and managed by the organization itself. So that is our on-premise strata. Now, how it changes in cloud? The first thing we have, what we have is called infrastructure as a service. So there are different vendors. We have AWS, of course. Then we have Rackspace. We have Microsoft Azure, Google Cloud Platform. So we have a lot of vendors which provide infrastructure as a service. So what is this infrastructure as a service? First of all, what is infrastructure? So if you see this diagram, this is our data center. Our network, storage. Network is a physical entity, right? We get routers, we create subnets, we we do wiring and stuff. Then we create a network. On top of it, and inside of this network, we have storage. So when we say storage, we go to shops and buy physical storages, and then we buy boxes to create servers using storage and network and CPU and RAM. Then using those servers, we can create a virtualized environment. And top of it, we install operating system, database, security, and application. So operating system, database, application, security, these are all software part. From virtualization above, everything is software part, but below that, everything is hardware. That's the infrastructure on which our IT runs. Now, make this infrastructure as a service. What is a service? So if you go to a pizza shop, you buy the end product of the pizza shop. That is a pizza. You go ahead and just eat it. The other way around of doing or eating pizza is you get everything, whatever utensils needed to create pizza, then pizza batter, the toppings, vegetables, so on and so forth, create it on your own and then eat it. So instead of that, what you do is you go to a shop or go to a restaurant and then buy pizza and eat it. So you are taking the service, you are removing the overhead of acquiring all those infrastructure, that is utensils, pizza batter, flour, vegetables, so on and so forth. You go to a shop, or go to a restaurant and buy pizza. That is what you are buying is pizza as a service, and you are consuming the pizza, and it is provided to you as a service. Similarly, infrastructure as a service. So in infrastructure as a service, we have data center, network, storage, servers, and virtualization. Everything is provided by the vendor. The software layer, which is operating system, database, security, and application, those are controlled by us. So in this case, AWS, if we talk about AWS is an infrastructure as a service provider. Of course, it has some other service models also, but we're talking about infrastructure as a service here. So they provision the data center, they provision network, they acquire all the storage, they build the servers and create the virtualization environment or virtualized environment. And on top of it, we install operating system, we install our application, we install database, we implement our security best practices. So that is infrastructure as a service. Then we have platform as a service. Like Elastic Beanstalk in AWS, we have Heroku, that's another one. So what is platform as a service? So this is the diagram of platform as a service. You write the application, that's it. Everything else is provided. So what do you need to write an application? Let's say a Python application. You're writing a Django framework. You're writing an application using Python Django framework. So what you would need is you need a machine. You need a database at the backend. You need an operating system. You need some security feature. So everything is provided to you. If you are using platform as a service, everything is provided to you, and you just go ahead and write the application. If you don't use platform as a service, what you have to do everything bottom up, right? Even if you use infrastructure as a service, you have to install the operating system, you have to install database, you have to implement security, and then only you can write your application. But in platform as a service, everything is provided as a service. You just go ahead and write the application, that's it. And finally, we have something called software as a service, like Google Drive, Google Docs, MS Office, Microsoft Office 365. So if you notice something, you don't install any software. Sorry. We do not install any of the software in our machine. What we do is we just go ahead and use the software. So if you use MS Office 365, if you log in using your Microsoft account, your Excel, your Word doc, your PowerPoint, everything will be there automatically installed somewhere in Microsoft Data Center, and you just go ahead and use it. You don't even have to install the software. So that is software as a service. Everything is provided to you. Everything is controlled by the third-party vendor. So might have guessed the blue portion is the one which you control, and the gray portion is the one which is controlled by the vendor. So in case of on-premise data center, you have control and you have to manage and control everything. But for infrastructure as a service, till virtualization layer, things are managed and controlled by the vendor. For platform as a service, the entire platform is given to you, including OS, database, security. You just write the application. But for software as a service, everything is given. So you just use the software as an end user. Then we have something called different deployment models. We have public cloud like AWS, Microsoft Azure, Google Cloud Platform, IBM Bluemix. So what is public cloud? You can access these things over internet. So you have internet connection, you can go ahead and access all these cloud services. from any of the vendors, as mentioned here, AWS, MS Azure, Google Cloud Platform, or IBM Bluemix. That is public cloud. Then we have something called private cloud. So in case of private cloud, the services are not accessible via internet. It is only accessible via intranet or within your LAN, within your organization's network. You cannot access those services outside of your organization's network. So that is private cloud. And eventually, or finally, we have hybrid cloud, which is the mix of both private and public. So there can be a lot of use cases of using hybrid cloud. For example, you do not, or your organization, for security or compliance reasons, they do not want to move their database out of their corporate data center. Although they are fine with moving rest of the services to any other public cloud provider, but not database, because that contains a lot of sensitive information, and there are some regulations, legalities, or compliances, because of which they have to keep their database servers on corporate data center. So in that case, they'll go ahead and use hybrid cloud, because some of the portions, or some of the applications would be in the public cloud, and some of them would be in private cloud. So there will be communication channel open between public and private cloud. So that's where hybrid cloud comes into picture. There's no one provides hybrid cloud services, or no, you have to deploy it on your own using any of the public cloud providers or private cloud providers. All right. Now, finally, the analogy, how your data center looks like. So if you have noticed, we have something called server in our data center, right? So the server is like, as I said, it contains a CPU and RAM. Of course, it contains a lot of other stuff like motherboard, so on and so forth. But the most prominent things are CPU and RAM. And then you have storage, where you store your data. Storage is always external to your compute capacity. So even in your machine, your hard disk is external to your RAM and CPU. But finally, storage is of course attached to the server, and these are considered as a whole, as a box. Now, on top of this box, you can install database, you can install application, you can install Java, Python, DB2, Oracle, MySQL, whatever you want. All right, so that's what it says. I mean, in this case, we are installing a database on top of this server. And then you have to put all these things inside of a network, which is your network. And so you have to make sure that everyone cannot access your server, your database. So we'll put firewall rules so that your traffic is filtered. Not everyone is allowed to access your database or your application or your network for that matter. Then we have a group of users or groups who have access to your network, who has access to your infrastructure, who has access to everything behind this one. So you'll have one team who will create these users who have access to your infrastructure. Then you might have some web servers, some website running. So you'll have a domain name. So that domain name would also point to your server if it is a web server. If this entire thing behind this network, instead of database, if you install a web server like Apache or Nginx, then it will be a web server. And you can serve a web server from your corporate data center also. And finally, to watch everything, you have Big Boss. You have to monitor each and every component of your data center. If anything goes down, that'll impact your end user. Eventually, it will impact your business. So you don't want anything to be down. You have to, there are some proactive measures, there are some reactive measures. So to take proactive or reactive action, you need to have something monitoring your entire infrastructure. So you'll have some monitoring in place. So for proactive or reactive measures, the monitoring will notify you using either page or SMS or email. So that's a very high level data center, very high level how data center looks like. Now let's see how AWS fits in all these things. And so you have, instead of server, you have EC2, which is a service provided by storage, provided by AWS. So instead of storage, you have EBS and EFS. Of course, eventually it is connected to your EC2 instance, which is your server. So instead of database or applications, you can have DynamoDB, RDS, or any web applications you want. Instead of network, you have VPC. So VPC is the network offering of AWS, EC2 is the server offering of AWS, EBS, EFS, S3 are storage offerings of AWS, DynamoDB, RDS are database offerings of AWS. Going forward, so in your corporate data center, you put firewall, but in AWS, you use something called security group and NACLs or network ACLs to implement the exact same functionality as that of firewalls. So security groups and NACLs are firewall implementation in AWS. And then the users. So in your corporate data center, there would be some, UAM team, user access management team, who would create users, create groups, and provide access to those users and groups. So in AWS also, we have a service for that. That is identity and access management. The functionalities are exactly the same. Domain. So how do you go ahead and get a domain for yourself? You register to any of the domain name providers like GoDaddy or something. You buy a domain name and then you attach the domain name to your server. So instead of going to GoDaddy or Verizon or whatever, AWS provides a service on its own, which is Route 53. So in monitoring part, we have an exhaustive monitoring in AWS, which is called CloudWatch, which monitors each and every component of AWS. Whatever service you can think of in AWS, everything is monitored by CloudWatch. And for proactive and reactive measures, we have SNS, SES. So this is a very high level. This is not all of the AWS services, which we'll be covering in the session. We'll be covering a lot more, but I just wanted to make an analogy and show you how AWS fits in to your corporate data center. So if you want to migrate your corporate data center to AWS, how do you map each component of your corporate data center to AWS services? And finally, why AWS? As you might have guessed, there's no capital expenditure whatsoever. What I mean by that is, if you have a corporate data center, if you want to start a new service or a new product, or you want to open a new data center, there are a lot of things involved. You have to buy land, you have to have building, you have to construct a building, you have to have electricity, you have to have security, car parking, so on and so forth. But if you are using AWS, you don't have to do anything what I have mentioned so far. Everything is taken care of by AWS. So zero capital expenditure. Don't have to build anything. There's no capex involved. Everything is charged on hourly basis and pay only if you use. So suppose you need a server, you need a database server, but the thing is that the database is not used 24/7. It's used only for 6 or 8 hours a week. So on your corporate environment, what you'll do, you'll have to buy a server, install database there, but you'll have to keep the server up and running, or if you want, you can stop it as well. But the point here is you have to buy the server. You have already paid for the server. But in case of AWS or cloud services, everything is charged on an hourly basis. You don't have to buy anything. You just rent it on an hourly basis. So out of a week, if you use it for 6 hours, you only pay for 6 hours. You don't have to buy the entire server as a whole. Then getting a new server is as easy as clicking mouse buttons. There's no question of having long meetings of capacity planning. You can just go ahead and check the different, map your application requirement with AWS services and get it. And you can use management console or command line interface to provision it within seconds using some mouse buttons, as I said. Provides high available solutions without an extra effort. So if you opt for AWS, high availability is inbuilt and disaster recovery is inbuilt. The only thing which you have to do is have to make your application use those features. But those features are already available. you can just go ahead and use it with no extra cost or effort for that matter. Security. So AWS has a lot of compliance. It is HIPAA compliant. It is PCI DSS compliant. It is SOC 1, SOC 2, SOC 3, SOC 4 compliant. So security is not a problem. If you want, you can have encrypted communication within AWS itself as well. So there's no problem of security. You get security inbuilt in AWS. So security for infrastructure is provided by AWS by default. You don't have to do anything to get that. Security for your applications will have to be managed by you. Of course, that's how it happens in any scenario. Even if you are in corporate data center, you have to manage the security of infrastructure plus the security of your application. I have flexibility and error shield. So what I mean by flexibility and error shield, suppose you're a solutions architect in your corporate data center. So a new application or a new migration project has come up. So what you do is you go ahead and check your application's usage, the workload for a period of time, and then you meticulously find out this is the amount of CPU or this is the amount of resource which I want. For example, if you're migrating a DB2 or Oracle database or a MongoDB database, for example, you'll do the analysis how much CPU is getting used, how much RAM is getting used for a period of 1 or 2 months, and then from that you'll find out that this is the amount which I need, and you'll buy server accordingly. But what if your analysis was wrong? So you could buy a lot more which than what is needed, or you could buy a lot less than what is needed. But the problem here is you cannot go ahead and return it. If you over provision, then there's no way you can cut down the budget. So you have made an error, we'll have to live with it. But in case of AWS, no problem if you have over provision or under provision. As you pay as you go, as you pay an hourly basis, you can increase or decrease the capacity as you need. You can increase or decrease the capacity after an hour, after a few days, or even after a few months. So it shields from capacity error, which is typically done in corporate data center. That's a huge advantage, and it saves a lot of cost. So if you see the Gartner's Magic Quadrant, AWS is the leader. Microsoft Azure is catching up, but it has a lot of time because AWS provides a lot more features than Microsoft Azure. Now the thing is, if you see Microsoft Azure, they have used the exact same concept of AWS. And AWS uses a lot more features, as I said, than Microsoft Azure. So if you learn AWS, learning other cloud technologies would be easier. Google Cloud Platform is again in the visionary part. It will take some time for Google to come out as a leader, and then rest all are in niche players. So that's all, and that's all I wanted to mention in this session. Thank you.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.